So lastly, what I want us to do is look at this question that I'm going to ask. I want you to think about what happens if we use more rectangles. Is it going to give us a better approximation or a worse approximation? What do you think? What's going to happen if we use more rectangles? Well, let's look at our example we've been doing so far. So let's use twice as many rectangles now. Let's use 4 rectangles. And I don't want to do all 3 options this time again, so let's just do right endpoints here. I'm just going to pick one of the 3 options. So let's start by talking about what would the width of each rectangle be. The width of each rectangle, well, what's the total length of my interval from 0 to 2? All right, take 2 minus 0 and divide by your number of rectangles is 4. So the width would be 1/2. Okay, so now here's 0. I'm going to again sketch my curve here, my part of my parabola I'm using. 2, 4. But now, because I have 4 rectangles, I'm going to have 1/2 here and a 3/2 here. And we're using, don't forget that we're using right endpoints. So in this first, so I have a rectangle from 0 to 1/2. You're going to pick the right endpoint, just right there. That will be the height of your rectangle. You have a rectangle from 1/2 to 1. Pick the right endpoint. That'll determine the height of your rectangle. You'll have a rectangle from 1 to 3/2. Pick the right endpoint. Draw your rectangle. And then finally, your last rectangle between 3/2 and 2. You're going to pick the right endpoint. So we have 4 rectangles that we need to calculate the area of. So the width of all of these is 1/2. So 1/2, the height of my first one came from plugging in 1/2 into my function. 1/2. The height of the second one, plug in 1 into your function, 1/2. Plug in 3/2 into your function, and a 1/2, 3/2. Plug in 2 into your function. Now these all have the same width, so I can factor out that 1/2 if I want to. And then f of 1/2 would be 1/2 squared. F of 1 would be 1 squared. F of 3/2 would be 3/2 squared. And f of 2 would be 2 squared. So I'm getting 1/2. 1/4 plus 1 plus 9/4 plus 4. So I'm getting 1/2, 10/4 plus 5. So that would be, if you get a common denominator, which would be 4, you would get 30 over 4, 15 over 4. So this is 3.75. And what I'll say is if you look back at what we had before when we had two rectangles before with n equals 2 rectangles. What did we get for our approximation? We got 5. And so if you look, remember 5 was an overestimate. This one is still going to be an overestimate if you look at your picture, because you're overestimating here. Those regions are not underneath the curve. So it's still an overestimate, but it's a better overestimate. So I'll say this gives us a better estimate for the area under the curve. And the reason why I say better here is because it's a smaller overestimate. It's still overestimating my area, but it's not as bad as what we had when we had 2 rectangles. So you'll see that as you take more and more rectangles, they're going to give you a better approximation for your area underneath your curve.